Hello, pre-calculus students. Today we are going to talk about section 6, so 12.6. So make sure you have your notes for section 6. Make sure you have something to write with, and you will want your formula sheet for chapter 12. Okay, we are going to talk about the binomial theorem. So binomial is when you're adding or subtracting two terms. It's binomial, two terms. And we're going to talk about Pascal's triangle. So we're going to start by just the simple expansion of these binomials. So if I have something to the 0 power, that just means anything to the 0 power is 1. And if I have x plus y to the first power, that's just 1x plus 1y. So you'll notice I'm kind of writing these in a really specific way. If I have x plus y squared, that would mean I would make a box and do x plus y times x plus y and fill in the box. And so I would get 1x squared plus 2xy plus 1y squared. I'm writing the coefficients on these because we're going to see a pattern. Now, if I want x plus y quantity cubed, that means I'm going to take this answer, so whatever answer I get here, right? So I'm going to take this, x squared plus 2xy plus y squared, and then I'm going to multiply that by another x plus y. You can see this is going to get really tedious really quickly, right? Because to the fourth power, I would have to take my answer for the third power and then multiply it by an additional x plus y. So mathematicians noticed some patterns that would help make this a lot easier. And that's what we're going to talk about today. Okay, so you might be wondering why I know these. How can I get these so quickly? So start looking at these and see what patterns you're noticing. Could you guess what this first thing is going to be? Right, notice this is x, first x, I know it's going to start with an x to the 4th. Well, I know it's going to end with? A 1y to the 4th. Any guesses about what this is going to be? You might be noticing 1, 2, 3, this is 4. Any ideas on the power? So it's going to be x cubed y, and this is going to be 4x squared y squared, and this is going to be plus 4xy to the 3rd. So now's the time to start really looking for some patterns, because what if I asked for it to be to the 5th? Could you guess what that is going to start out as? So probably you're like, oh, it's going to be 1x to the 5th for sure. Now these coefficients have significance. So if you remember Pascal's triangle from before, and here it is, you see that the coefficients on those expansions are the same as Pascal's triangle. Okay, so if we were to get the expansion of x plus y to the 5th, I know these would be my coefficients on that. And there's lots of different patterns that exist in this. One of them is, if you look at your powers of x, they start out as x to the 4th. If this is the 4th power, the highest power here is going to be the 4th. And then this term is to the 3rd, and this term to the 2nd, to the 1st. And then this is as though it's x to the 0, so it's gone. And then the y's do the reverse. So this is like no y to the 0, y to the 1st, y to the 2nd, y to the 3rd, y to the 4th. So if I wanted to expand x plus y quantity to the 5th, I know I would start with x to the 5th. And then my next term I know would have a 5. And then the powers on the x's would decrease, and then the y's would increase. And then my next term would be 10. And now the powers decrease, so x to the 3rd, y to the y powers increase to the 2nd. Okay, the next coefficient is 10. Powers on the x decrease, on the y increase. My next coefficient is 5. Powers on the x decrease, powers on the y increase. And then my last coefficient is 1, no more x's, and so it's just y to the 5th. Okay. Now, there are so many different patterns in Pascal's triangle. Now, Pascal wasn't the first person to discover these patterns. He was the first one to put them into a triangle, so he gets all the glory. Okay, so you might be noticing, oh, ones, 1, 2, 3, 4, 5, 6, and it would keep going and going this way. We've got symmetry, right, that keeps going. How do you get from one row to the next row? Like if I wanted to generate the 6th row. So I know I start with a 1, and I know this would be a 6. So you might be noticing up here, like 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4. Here, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5. So if I wanted to generate this row, 6, 5 and 10 is 15, and then this is 20, 15, 6, 1. Once I get on the other side of the maximum, I know I just have symmetry. Now looking at my examples below, I notice my highest power is a 9. So take a minute and go ahead and crank this out 9 rows. But again, once you get on the other side, like 35 and then 30, I knew it was what it was going to happen on the other side of that. So it's not as painful as it seems. Now, if the reason I had you grab your formula sheet is because Pascal's triangle is on it. So you don't have to memorize it, but you guys, if you start with 1, 1, 1, you can go from there, right? If you have a triple, right, you just 1, 2, 1, 1, 3, 3. It's not hard. Tedious, maybe, but not hard. You could do it if you had to do it. Okay, so now let's talk about how we could expand binomials using Pascal's triangle. Because if I wanted to do this without Pascal's triangle, I'd have to write it out 4 times and you have to do 4 boxes. And you remember when we did polar coordinates and you had to power the complex numbers in rectangular form, it would be really tedious. And then we talked about polar form because it would be faster. This is kind of the same idea. Now, some people are like, oh, this is so tedious, but just put it in perspective. What would be worse? Like the ninth power, yuck, right? So you might think this is tedious, but it could be way worse. So just put it in perspective. Okay, so if this is the 4th power, I want to use row 4. Now, another thing when you talk about the rows, this is like row 0. We're going to refer to this as row 1 and row 2. So whatever the second number is, that's like your row number. So I'm not going to say, I'm going to be very careful to try not to say for this the 4th row, because technically the 4th row is 1, 2, it's this one. Okay, but that's not what I noticed with the pattern. It should be the coefficients like 1, 4, 6, 4, 1. Okay, so I want to refer to these row numbers a little bit more carefully. So I want to use row 4 of Pascal's triangle. I know those are going to be my coefficients. So I'm going to have 1 times something, plus in this term I'm going to have 4 times something, plus in this term 6 times something, plus 4 times something, plus 1 times something. Okay, so I have 5 terms. So if you're in row 4, you actually have 5 terms. Whoops, I said row 0, but I wrote row 1. Row 0, row 1, row 2, row 3, row 4. Okay, so then what I noticed was that the first term, which were the x's, they decreased in degree. So instead of having x now, though, I have this x plus 4. So I'm going to have the 4x. It's going to start to the 4th power, and then it's going to be like this is to the 0 power. Okay, now you can write that if you want, and I will for this example, but you don't have to because it just equals 1. Now in this term, it's going to be 4x to the 3rd power, right? The x's decrease, or whatever this first thing is decreases, the second thing increases. This will be now 2y to the 1st. Okay, in this one, it will be 4x to the 2nd, and then 2y to the 2nd. And then here, 4x to the 1st, and 2y to the 3rd. And then here, it's like 4x to the 0. Again, you don't really need it. And then 2y to the 4th. Now notice, I put each of these in parentheses because the power is applied to everything. It's not just on the variable, it's on the whole thing. So for this here, like this is 1, but I need to think of this as 4 to the 4th and x to the 4th. So that's 256x to the 4th. Okay, this I have to think of it as 4 times 4 cubed times x cubed times 2 times y. Right, those are both to the 1st. So then you can think, okay, I have to multiply the constants together. So that's 4 times 4 third times 2. Well, that's really 4 to the 4th times 2. So that's 5, 12, and then I got an x cubed and a y. Okay, now on this one, I've got a 6 times 4 squared times an x squared times a 2 squared times a y squared. Okay, make sure that power on the outside is applied to everything. And if you don't write it in parentheses, if you were to just write 6 times 4x squared times 2y squared, that just means 6 times 4 times 2, which is way different than 6 times 4 squared times 2 squared. So please, 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 number 1 mistake is to not put stuff in parentheses, please. Some people are still not going to do it, I know, and maybe you will. I'll do it and I'll be so happy. Okay, here, 4 times, this will be 4 to the first times x to the first times 2 to the third times y to the third. So 4 times 4 and then times 8. So 128, and then I have an xy cubed. And then here, this is to the 0, that's gone, so 2 to the 4th. This is 1 times 2 to the 4th times y to the 4th. So plus 16 y to the 4th. You should have 5 terms, right? None of these are like terms. They don't all have the exact identical variable part. You are done. All right, so try the next one. Now, when you do the next one, this is like your first thing. You have to use the entire, like you have to think of this as negative 3y, because it's like plus a negative 3y. So careful with that. Please with the parentheses. Okay, so try it. This is cubed, so I need to use row 3 from Pascal's triangle. So I have 1 times some stuff, plus 3 times some stuff, plus 3 times some stuff, plus 1 times some stuff. Okay, I'm going to take the 2x, going to start it out cubed. Okay, no y's in this one. And then here, the 2x is going to be squared, and I'll have a negative 3y to the first in parentheses. Here, my 2x will be to the first, my negative 3y will be to the second. And here I'll have no x term, and I'll have negative 3y to the third. Another interesting thing to notice is that whatever power you're taking it to, so here the third power, what's the sum of my exponents? 0 and 3 is 3. 2 and 1 is 3. 1 and 2 is 3. That's 3. And that happened up here also. 4 and 0 is 4. 3 and 1 is 4. 2 and 2 is 4. 1 and 3 is 4. Another way to kind of just check yourself. And that happened in all the other ones as well. So now we're going to expand. So I have 1 times 2 cubed times x cubed. So that's 8x cubed. Here I have 3 times 2 squared times x squared times negative 3 times y. Okay, so I have negative 36. I'm going to write minus 36, all right, not plus negative, x squared y. Right here, I have 3 times 2 times x times, I'm going to put this negative in parentheses before I square it so I don't screw up the sign, times y squared. Because negative 3 squared is really positive, right? So I have 9 times, that's 6, so I have plus 54 xy squared. All right, and then this last one is 1 times, again, I'm putting that negative in parentheses so I remember it's negative 3 times negative 3 times negative 3. So it's negative 27 or minus 27y cubed. All right, now the last examples ask us just to determine the 5th term of this expansion or the 6th term of this expansion. It does not actually ask us to expand the whole thing, okay, which would be sort of a pain in the butt. We see how big this is up here. I just want the 5th term. So I'm going to use some of the patterns that I notice up here. First of all, if it's the 5th term and this is the expansion, I want to use row 9. So I'm going to look up here. Here's my row 9. In the 5th term, what would the coefficient be? So here's my 1st term, my 2nd term, my 3rd term, my 4th term. Here's my 5th term. Would have a coefficient of 126. So 126 is what my coefficient would be. Then I'm going to start with x to some power. Well, think about what power would it have been to here? I would have started out with x to the 9th, x to the 8th, x to the 7th, x to the 6th, x to the 5th. So x to the 5th, and then y to the, well, I just talked about how the exponents have to add to be this power. So if this is 5, this has to be 4. And so that would be my term. I don't have to go through the whole thing. Now you might be like, oh, well, that's the 5th term and that's 5. And so that's super easy. Now it only works out that way if it's like on the first half of the triangle. Okay, if it was something on the second half of the triangle, it's not necessarily just that number, right? Because if I had said the 7th term, right, this wouldn't be an x to the 7th on that, right? Because x to the 7th happened back here. Just be careful. So we'll see that in this one. So start by thinking about, okay, what's your first coefficient? What are you pulling from the unit circle, or not the unit circle, from Pascal's triangle? And then what would the powers on these be? Okay, so let's see. The 7th row I want to use because it's the 7th power, right? 7th power means use the 7th or use row 7. Careful on that, right? Use row 7. Okay, and I want the 6th term. So 1, 2, 3, 4, 5. This would be my 6th term. 21 will be my coefficient. Now, this is going to be 4a to what power? Right, so if I think about it, this would start 4a to the 7th, 4a to the 6th, to the 5th, to the 4th, to the 3rd, to the 2nd. So this would be 4a to the 2nd. This is what I'm talking about. Just because it's a 6th term does not mean that's a 6. It happened here. It does not always happen. Again, the way I knew it was squared is because I thought, okay, if I were starting this whole expansion out, I would have had 4a and I would have started it to the 7th power and then worked my way down to the 6th, to the 5th, to the 4th, to the 3rd, to the 2nd. It would have been to the 2nd with that coefficient. And so then the 3b, well, these have to add to be 7. So if that's 2, this has to be 5. Now this I have a little bit more work to do than I did on that one because I can expand this, right? So, or simplify it. So 21 times 4 squared times a squared times 3 to the 5th times b to the 5th. So I can multiply all my numbers together and it's pretty big. 81,648, and that would be a squared b to the 5th. Okay, so when it talks about using the binomial theorem to expand, it's talking about this.